class on periodic table. Okay, so as you can see on the board, right on the board, we have our own periodic table on the board. Now, most of you must have seen this table while in secondary school. You have known this table, you have come across it several times. But this time around, we're going to go deep into this table to understand what this table is actually talking about. So, looking at this table, you can see that the table is divided into what? Groups, and or you can say column and what? Row. So these are the columns, these are the columns, all these are the columns, and these are what? The rows, or you can call it what? Period. Okay? The column is also called group. Okay? Then the row is also called what? Period. Now, before we talk about this table, let's talk about how this table was discovered. Okay? So most of us know about a man called Mendeleev. Mendeleev was the one that actually constructed this table. Okay? But in his construction, he did the construction using atomic mass as the basis, right? But the modern periodic table, the elements in the table are arranged based on their atomic number. Let me show you. For example, if you start from here, hydrogen is the first one, okay? Followed by helium, second element, number 2. Followed by what? Lithium, number 3. So if you notice the arrangement, it is arranged according to increasing atomic number. This is 1, this is 2, this is 3, and so on and so forth. And if you keep going, you get it that way too. Now, before we proceed, this table is divided into 2, just like I told you. The groups and the what? The period. Now, even in the groups are also divided into what? 2. If you notice here, we have the A, the B group. So these A are called the main element. They are the main elements, or you can call them representative elements. And these representative elements are grouped into what? 8. The first one, which is this, is called the alkali metals. The second one, which is the group 2A, is called the alkali earth metals. Now, skip from here to this place. In this video, we are just going to analyze the table, so that when you see the table, you will understand that this is this, this is this. Okay? Now, skipping from here to here, skip this side. Let's skip this side. Let's go to this side. Okay? After, like I've told you, I said that the groups are 2 main groups. Okay? The first group is called the main group, or we call them representative elements. They include the first one here called the alkali metals. The second one is called group 2A, is called alkali earth metals. Skipping from here to here. Skipping from here, from this point to this point. The next group is what? Group 3. Okay? The group 3 is called, it's a family called the boron family. Okay? The first element here is boron, so we call it the boron family. Okay? The next one is what? The carbon family. Okay? Which is the group 4A. Then the next one is the group 5A. Okay? They are also called the nitrogen family, or you can call them the pycnogens. Okay? You can call them the pycnogens. Then the next one is the group 6A, which is called the oxygen family, or the chalcogens. Okay? Then the next one is group 7A, called the halogens, the elements in the halogen. Okay? Called halogens, or group 7A. While the last ones are the noble gases, or the inert gases, or the rare gases, which are called group 8A. So this group I mentioned, they make up the main element, or the main group, called representative group. Then the next group is called the transition elements. From this point to this point, from here, make up the word transition elements. Transition elements. Okay? These transition elements consist of all the elements in this place and also all the elements that are here. So we have the inner transition element and the outer transition what? Element. So take a look at these elements. Now notice something here. In the transition elements, the groups, the number of groups you are seeing here are 10. But out of these groups, the 3 groups here, these 3, the group in this iron, cobalt, and nickel, the 3 of them are regarded as one group. And we call them the group 6b. Okay? The elements here are regarded as what? One group. So we call them, so it is still 8 groups that are here. The same 8 groups that are here, that are also here, is what we also have here. But you might think it is 10, but it's not 10 because these 3 are regarded as one group. Okay? Now, take a look at this table. There are so many things you can know about this table. Not just what I just said so far. With this table, you should be able to identify which ones are metals, which ones are non-metals, and which ones are metalloids. Also, from this table, you should be able to know how to what? Classify these elements according to their what? Block. Some of the group here consists of the S block, the P block, the D block, and the F block. So, let's analyze this table one by one. Look at the group 1A. All the elements in the same group, they have the same valence electron. That's number one thing you have to know. What is valence electron? Electrons that reside in the outermost what? Shell. The valence electron in the group 1A here is just 1. How? Let me show you. Hydrogen has atomic number 1. So the valence electron is just what? 1. Lithium has atomic number 3. The valence electron for lithium is 1, 2. So valence electron is the electron residing at the outermost shell. So elements in the same group have the same valence electron. That is number one feature you have to take note of. Okay? For example, if you look at the group 3A, they have valence electron of 3. Aluminium has a valence electron of 3. If you arrange the electron in shells, you notice that what? That the last electron is going to be 3 electrons, which is called the valence electron. Now, the next thing I want us to observe in this table is across the period. As you go across the period, as you go across each of the periods, the valence electrons increases by 1. Take note. As you move across the period, the valence electron increases by 1. Meaning that if the valence electron here is 1, the next one will be 2, the next one will be 3, the next one will be 4, so on and so forth. So these are some of the things you need to know before we go into the word, the periodic table proper. Now, having talked about these valence electrons both in the period and in also the group, the next thing we'll talk about is the classification of this table based on the blocks. Okay? Now, if you are asked to classify this periodic table in terms of the blocks, there are 4 blocks in the table. There are 4 blocks. The 4 blocks in the periodic table, are the S block, the P block, the D block, and the what? F block. These are the blocks, right? So which one makes up the S block? Which one makes up the P block? Which one makes up? So you need to know how this table is arranged in terms of block. Okay? Take note. The S block consists of the group 1A and the group 2A. The P block consists of group 3A down to group 8A. So it means that this, down to this, all of them belong to what? The p block. The only exception is helium. Helium and hydrogen are not actually qualified to be in this group because helium, from the configuration, it has an s block. That is why we place at the top of this place. It's not qualified to be in group A because it is only the component of the group A that does not obey the p and the s block rule. Okay, so aside helium, all the elements here are in the p block. The same thing from here, from this place down to this side. The next block is the d block. The d block consists of all the elements you see that are from here. Watch, from here, from 1b, let's say 1b down to what? 8b. This one you are seeing outside here is called the lanthanides and the actinides. These ones, the lanthanide and the actinide, is the one that make up the F block. So the F block consists of lanthanides and actinides. So the periodic table is further classified in terms of block. So if you are asked what block is lithium, because lithium is in group 1A, the block is what? S block. If you are asked what is the block of chlorine, because chlorine is in what? Group 7A, and group 7A is among the p block elements. So note that the periodic table is also further divided into groups and what? Period, and also in terms of blocks. Now in terms of groups, I have explained the groups. The next classification is in terms of what? Period. In terms of period, we look at the what? The RAL. The RAL. So in terms of period, we have period 1, period 2, period 3, period 4, period 5, period 6, period 7. Okay? In terms of period, we have period 7. So now, looking at this thing now, you can now be able to see that all the elements you see in this RAL belongs to period, are in period 7. Period 3, sorry. All the elements in this RAL are in period what? 4. While all these ones are in period what? 5. So the period is referring to what? All the elements in the what? In the RAL. In the row, or you can call it RAL. Now, also, the period 1 talks about just 2 elements. Hydrogen and what? Helium. They're the only 2 elements in period 1. So, understanding this table is an important step in going further into what is involved in this topic. Okay, so now I have been able to break down that the periodic table is elements are arranged based on their atomic number, not their mass number. That is the modern periodic law. Also, we have been able to see how the groups are further divided into what? Main group and the what? Transition what? Elements. And also, we have also looked at how the group is also classified in terms of what? Block. The S block, the P block, the D block, and the F block. So all the elements in this row, in this column, all the elements here belongs to the what? F block. While all the elements here belongs to the what? D block. Then this belongs to the what? P. While this belongs to the what? S. Now, looking at this table, just like we have explained all these things now, there are some specific patterns that takes place in these chemical elements. Those specific patterns, we call them periodic what? Trend. Okay? So some of those things are the things you see in your exam. Some of those periodic trends include have ionization energy, have metallic character, we have atomic radii, we have electronegativity, have electron affinity, these are the 5 major trends you should know. You should know what happens to these trends as you move either down the group or across the period, and why the trend is taking place. Okay, so we're going to look at each of these trends one after the other to actually find out what happens as you move down the group or across the period. Now, before we are able to look at these things, let's start with the first one. The first one called ionization what? Energy. Now the question is, what is called ionization energy? What is it all about? Now this is the energy that is being produced, or the energy involved when a gaseous element loses an electron from its neutral state. I repeat, this ionization energy is the energy that is released when a metal or a gaseous element loses its outermost electron. Now, this electron that is lost must be the valence electrons, definitely. Okay, so the ability to lose this electron is what we call the ionization potential. The energy required to remove that electron is what we call the ionization what? Energy. And this energy varies as you move down the group or across the period. Now, let's talk about what happens as you go down the group. This energy, will it either increase or decrease? Now, as you go down the group, the ionization energy decreases. So, as you go down the group, the ionization energy decreases. Now, why does it decrease as you go down the group? It decreases because as you go down the group, it decreases because as we go down here, there is formation of what? New shells. And due to these new shells that are being formed, the distance between the nucleus and the electron is far apart. And the force of attraction, so as you go down the group, the ionization energy decreases. Why does it decrease? It decreases because as you are going down the group, there is formation of what? New shells. Okay, and this formation of new cells, the distance between the valence electron and the nucleus are far apart, and because of that, there is something we call effective nuclear charge. That is the force of attraction that is holding this nucleus and the outermost electron. So if the distance is far, the ability to lose the electrons becomes very high, and due to that, the ionization energy is going to what? Decrease. Now, as you go down across the period, as you are going across the period, there is no new shell formed because all the elements in this route have the same number of shells. Okay, so because of that, there is no new shell formed, and the distance from the nucleus to the what? To the valence electron is somehow close. So due to that, the force of attraction holding those two is very high. So it's going to require a very high energy to remove an electron. So as you move across the period, the ionization energy increases. While as you go down the group, the ionization energy does what? Decrease. So the next periodic trend we talk about is what? Metallic character. Remember, we just talked about this now. So the next one we talk about here is the metallic character. So this metallic property of an element is that property of an element to conduct. The metallic property is actually the property an element has that helps it to what? Conduct what? Electricity. So metallic character is a unique property peculiar to elements that can conduct what? Electricity. So now, this metallic character, what happens as you go down the group? Also, what happens as you go across the period? Now, as you go down the groups, the metallic character, that is their tendency to conduct electricity. As you go down the group, this metallic character increases. Why or how? As you are going down the group, remember that as you are going down this group, the formation of these new shells increases the size of the what? Elements. And at the same time, their effective nuclear charge decreases, because the more an element is getting big, the distance from the nucleus to the valence electron is very far. So the force of attraction, which is that effective nuclear charge, is very weak. So the tendency, it ionizes and remove electron, because the only time something can conduct is when it ionizes. So if the element has the ability to what? Donate or remove electron, ionize, then it has a tendency of what? Conducting. So since we know that the sizes increases, and as it increases, the electrons have the ability to what? To split up, to form a charge, which can what? Form what? Ions that can what? Conduct. So as you go down, the metallic character increases due to what? Decreasing what? Effective nuclear charge. But class, as we go across the period, the metallic character decreases. Why? Because as you move across the period, the effective nuclear charge increases. And if the effective nuclear charge increases, the electron will be tightly bound to the what? Nucleus. So the tendency of ionizing to form ions that can conduct is very, very what? Slim. So as you go across the period, the metallic character decreases. While as you go down the group, the metallic character does what? Increases. So you should know why it's increasing. It is increasing down the group because of what? The shells. The electrons are very far. They will ionize and form ions and then conduct. But as you move across the period, the force of attraction is what? Is very, very slow. The force of attraction is very, very high, and then causing the nucleus and the electrons to be tightly bound, so they cannot ionize, and therefore they cannot what? Conduct. Now, the next periodic trend is what? Atomic radii. What is atomic radius? Atomic radius is simply the distance between the nucleus. If this is the nucleus of an atom, if this is nucleus, if this is nucleus, the distance between this nucleus and the outermost electron, the distance between this nucleus and the outermost electron, that's what we call atomic what? Radii. So how does this atomic radii, what happens to the trend as you go down the group or across the period? As you go down the group, the atomic radii increases. Atomic radii is like the size. Atomic radii is talking about the size of the element, okay? Now, the size or the radius increases as you go down. You know why? Because the more you go down, the more you see new shells that are being formed. And the distance of the shell and the nucleus keeps on getting large. So as you go down, the atomic radii increases. Okay? That makes sense. As you go across the period, the atomic radii decreases. Why? If you look at this period now, across the period, you notice that there is no new shell. Okay? There is no new shell. But as you go across this period, there is something we call effective nuclear charge. That effective nuclear charge is like a force of attraction holding the electrons that are outside and the nucleus. As you are going across this period, this effective nuclear charge increases. And when it increases, the force of attraction keeps shrinking the element and reducing the size of the element. So it's just like something now. So it's just like having two things here, and this one is attracting this one to itself. Okay, and the more it brings together, the more the size will become reduced. So as you are going across the period, a force of attraction called effective nuclear charge increases, thereby reducing the sizes or the radius between the electron and the what? Nucleus, causing the radius to become what? Very small. So as you go across the period, the atomic radii decreases. But as you go down the group, the atomic radii increases. Why? Because of what? New shells are being formed, thereby increasing the distance of the what? Electron and the what? The nucleus. But as you go across the period, the effective nuclear charge increases, which helps to what? Reduce the distance between the nucleus and the what? Outermost what? Electron. So the next one we'll talk about here is electronegativity. This is very simple to explain, very simple, quite simple. I'll do that quickly. Now for electronegativity, it is simply the ability of an element or an atom to attract a pair of electrons from its participating atom, right? The ability of an element to attract an electron or a pair of electrons is called electronegativity. Now, as you move down the group, the electronegativity does what? Decreases. Why? Because of what? Decreasing effective nuclear charge. Remember that as you go down, the effective nuclear charge decreases here. So due to the decrease in the effective nuclear charge, there will be a decrease in what? In the electronegativity, which is the ability of this guy to attract an electron to itself. Okay? So across the period, the effective nuclear charge increases, right? So as the effective nuclear charge increases, the electronegativity does what? Also increases. So it is directly proportional to the effective nuclear charge. As it increases, the electronegativity does what? Also what? Increases. Last periodic trend to talk about here is electron affinity. Electron affinity is simply the tendency of an element to what? Accept electron, a pair of electron, usually non-metals, okay? The tendency to accept a pair of electron is what we call electron affinity. So this electron affinity, what happens as you go down the group? It is also proportional to the what? Effective nuclear charge, directly proportional. As you go down the group, the electron affinity decreases. Why? Because of what? Decrease in effective what? Nuclear charge. So if there is a decrease in effective nuclear charge, the electron affinity decreases. Now as you go across the period, the electron affinity increases. Okay? Due to what? Increase in what? Effective what? Nuclear charge. Remember I said that the effective nuclear charge is the force of attraction that is holding the nucleus and the what? And the electron. So electron affinity increases as you move across the period and then decreases as you move down the group. So these are some of the questions they can ask you in exams. A multiple choice question. What happens to this as you go across the period or as you go down the group? So take note and look at all the things we have said and link it to the what? To the table and be able to understand what is going on. I believe that all this we have said is helpful to understanding this periodic trend and also the properties of the periodic table. Thank you.